So we are into the final section of Chapter 1. We're going to look at absolute value equations and inequalities. So we're going to define what absolute value is and then look at what happens when we put those into equations or inequalities. So first, just a quick reminder of what absolute value is. Absolute value, you might think as the function that makes a number positive, but absolute value is just describing a number's distance from zero. Now, distance is a positive value. You can't have a negative mile. You can have a negative displacement or a negative direction, but a distance is always going to be a positive real value. So, quick examples, the absolute value of 3 is 3. The absolute value of negative 3 is 3, because both of those numbers are 3 away from 0. Absolute value of 100 is 100. What's the absolute value of negative 100? 100, right? So absolute value, pretty easy to evaluate. But it's important to understand that it's the distance from 0. That's going to help us out in just a little bit. So here are some very simple absolute value equations that we'll start with. The first one, the absolute value of x is 3. So this is asking us what values have a distance of 3 from 0. Right? So in this case, if we want the absolute value to be 3, then x could either be 3 or x could be a negative 3. So we actually have two solutions for any of these absolute value equations. Looking at this next one, the absolute value of x minus 4 is 2. So if x minus 4 is going to be 2 away from 0, then x minus 4 needs to either equal 2 or x minus 4 needs to equal a negative 2. So to get rid of that absolute value, we just set the inside equal to the right side, and we set the inside equal to the opposite of the right side, and then we solve each of those on their own. So we add 4 to both sides all the way across the board, right? And x could either be 6 or 2. So 6 and 2 are the two solutions there. And then to make things a little bit trickier, what if we have the absolute value of x minus 6 is equal to negative 1? Well, let's just get the absolute value by itself. So add 6 to both sides, so the absolute value of x is equal to 5. So x could either be 5 or x could be a negative 5, and there's nothing left to solve there, so those are our two solutions. In some cases with the absolute value, we might have what's called an extraneous solution. In that word extraneous, you maybe see the word extra, and that's essentially what this is. It's an extra solution. It's one that we might find at the end, but it actually doesn't work in the original problem. So in absolute values, that's possible that could happen, but there's a giveaway at the start that tells us that there might be. So let's solve this first one. We have 4x plus 12 equals 28. So 4x plus 12 could equal a positive 28, or 4x plus 12, if that equals a negative 28, then our equation is happy. So subtract 12 from both sides, so we would have 4x equals 16, divide by 4, and x is 4. That's one of our solutions. And then on the next one, subtract 12 from both sides, and that's a negative 40. Divide by 4, and x is a negative 10. That's one of our solutions. So what we need to do is check and see that both of those work. So if I take and plug in 4, so 4 times 4 plus 12, and the absolute value of that, does that equal 28? Does that check out? So 4 times 4 is 16, right? Plus 12 is 28. That's inside the absolute value. Absolute value 28 is 28. So, yeah, 4 is a solution. Now what about negative 10? So 4 times negative 10 plus 12, absolute value of that, does that equal 28? Well, 4 times negative 10 is a negative 40, plus 12 gives us a negative 28, and that's all still inside the absolute value. And absolute value of negative 28 is a positive 28. So yeah, that checks out. So both of those work. There's no extraneous solution. So what about this one over here, where we have absolute value of 4x plus 10 equals 6x? This one's a little different. We've got this x hanging out outside of the absolute value. So let's see if that makes any sort of difference. So again, we'll start the same way, where 4x plus 10 could equal 6x, or 4x plus 10 could equal a negative 6x. In this case, subtract 4x from both sides, and we have 10 equals 2x, divided by 2, and we get 5 for our first solution. Then subtract 4x, and we would have 10 equals a negative 10x, divide by negative 10, and x is a negative 1. So there's two solutions. Let's see if those actually check out. So if we plug in 5, we have 4 times 5 plus 10 equals 6 times 5. 4 times 5 is 20, plus 10 is 30. Absolute value of that is 30, and 6 times 5 is 30. That one checks out, and we're good. Plug in the negative 1. We have 4 times negative 1 plus 10 equals 6 times negative 1. 4 times negative 4 times negative 1 is negative 4 plus 10 gives us a 6. That's inside the absolute value. Absolute value of 6 is 6. 6 times negative 1 gives us a negative 6. Is 6 equal to negative 6? No, that doesn't actually work in the original equation. We have to go back and check that in the original. If you only go back and plug that negative 1 in here, it's going to work out. But we have to go back and plug that into the original. Negative 1 ends up not working, so we reject that as a solution. That is an extraneous solution. So the giveaway is if there's an x outside of the absolute value, there may be an extraneous solution. Okay, so we have to check both of them. It's possible that both solutions work. It's possible that neither solution works. It's possible that one of them works. So we need to check both of them to see if they do actually work. And if they do, or once we do that, then we're good. If there's no x outside of it, if your x is only inside the absolute value there, you don't need to worry about extraneous solutions. You're going to have two solutions. So what if we throw an absolute value into an inequality? So what if I say that the absolute value of x is less than 5? Then what we're really saying there is that x is less than 5 from 0. Right? Absolute value is the distance. So the absolute value of x is the distance from 0 for x. So what we're saying is the distance is less than 5. So if the distance from 0 is less than 5, then that means that x needs to be less than 5, or x has to be greater than a negative 5. Right? And I think this actually ends up being an and, because if we go ahead to plot those, so here's 0, negative 5, and 5. If the distance is going to be less than 5, then it needs to be between that negative 5 and 5. So we should actually say that this is an and. Okay? So if the absolute value is less than something, you're going to end up with an and. Now if the absolute value is greater than something, so let's say the absolute value of x is greater than 2, that means that x is more than 2 away from 0. Then the statements that we get would be x needs to be more than 2, or x has to be less than a negative 2. Right? So that when we graph that, negative 2, 0, and 2, we're more than 2 away from 0 on either side, so that one ends up being an OR. So if an absolute value is greater than, then you end up with an OR of inequalities. And just like on the equations, it turned into 2 equations, it turns into 2 inequalities. So let's walk through a couple of examples together. So this first one, we have 3x minus, or absolute value of 3x minus 7 is greater than or equal to 58. So we're saying that the distance from 0 has to be greater than 58. So 3x minus 7 is greater than or equal to 58, or 3x minus 7 has to be less than a negative 58. So add 7 to both sides. Now what does that get us? 65. And then divide by 3. And x has to be greater than or equal to 65 divided by 3. We'll go 21 and 2/3. And then on the other side, add 7. And we get less than or equal to, what would that be? A negative 51. Divide both sides by 3, and x is less than or equal to, is that 17? Oops, 51 divided by 3, 17. So negative 17. I think on this one I probably meant for that not to be a 58. That was probably supposed to be something else. I bet that's a typo. But either way, it's still solvable. So there's negative 17. 21 and not 1/3, that should be 2/3. And we are greater than or equal to that 21 and 2/3, so we're out to the right. And we are less than or equal to that negative 17, so we're out to the left from there. So the distance is greater than, so we end up with an OR. We are going away from each other with that graph. Our other example looks definitely like it'll work out better. So here we have x minus 2, or absolute value of x minus 2 is less than 3. So the distance is less than 3, so it's going to have to be between two values. So x minus 2 has to be less than 3, but x minus 2 is also going to have to be greater than a negative 3 to be inside of those values. So add 2 to all of the sides, and we get x is less than 5. Or add 2 and we get x is greater than a negative 1. So negative 1, 5. We are less than the 5. We are greater than the negative 1. So we have a graph shading between those values. And so that's how we graph or solve the absolute value equations and the inequalities.